minima and maxima for any given function f of x. The first derivative is represented by f dash of x and the second derivative is represented by f double dash of x. If f dash of q equals 0 and f double dash of q is greater than 0, then f of x has a minimum at x equal to q. If f dash of q equals 0 and f double dash of q is less than 0, then f of x has a maximum at x equal to q. For a function, if f double dash of q is positive, then the curve will be bending upwards. If f double dash of q is less than 0, the curve will be bending downwards. To find the minimum and maximum points on the graph of y equal to f of x, we need to follow the following steps. First one is we need to decide the domain in which you are interested. We need to find an expression for f dash of x, the first derivative, and then we need to list the values of x in the domain for which f dash of x is 0. Next step is to find the second derivative of the given function. For each value of x that we found in step 3, we need to find the sign of f double dash of x. If the sign is positive, the graph has a minimum point. If we get a negative sign, it will be a maximum. The last step will be for each value of x which gives a minimum or maximum, we need to calculate f of x. Find the minimum and maximum points on the graph of f of x equal to x power 4 plus x power 5. Here the domain is the set of all real numbers. First we find the first derivative of the given function. F dash of x is equal to x power 3 times 4 plus 5x. We make it equal to 0 and find the values for x. We get two values, x equal to 0 and x equal to negative 0.8. Now we find the second derivative of the given function. F double dash of x equal to 4x squared times 3 plus 5x. For each value of x, we find the sign of f double dash of x. So f double dash of negative 0.8, we get value which is less than 0. So at x equal to minus 0.8, the curve will have a maximum. And we test it with 0. We test the second derivative with 0. We got value equal to 0. So we follow the old procedure. We check the gradient in between the values negative 0.8 to 0. Gradient is less than 0. And again we test for the values which are greater than 0. For x greater than 0, we got the gradient as positive. So we can conclude that x equal to 0 gives a minimum point. So the maximum point is minus 0.8 comma 0.08192. Those are the x and y coordinates. And the minimum point is the origin 0 comma 0. We need to find the minimum and maximum points on the graph of y equal to x plus 1 whole square over x. Here the domain is all real numbers except 0. The given function can be rearranged as y equal to x plus 2 plus x power minus 1. We differentiate it to get the first derivative, dy over dx equal to x square minus 1 over x square, and we make it equal to 0 and find the values for x. We get two values, x equal to plus 1 and minus 1. And now we find the second derivative of the given function, d square y over dx square equal to 2 over x power 3. And for each values that we found for x, we test the sign of the second derivative. D square y over dx square equal to minus 2 when x equal to minus 1, and d square y over dx square is equal to 2 when x equal to 1. So minus 1 comma 0 is a maximum point and 1 comma 4 is a minimum point.